Hey class, this is going to be notes for 9.5, which is going to be on finding missing angles using trig. So last time we used the trig functions to find the missing sides of right triangles. And so today we're going to use those trig functions to find the missing angles. And so what you need to know for sure is remembering the SOHCAHTOA to help us remember that sine is opposite over hypotenuse, cosine is adjacent over hypotenuse, and tangent is opposite over adjacent. Remember, that's in a right triangle, and the opposite and adjacent sides are based off of that angle. If the hypotenuse is always across from the 90, if the angle is right here, then straight across is the opposite side, and the side that's like touching it is the adjacent side. So that's how you label that triangle, and then knowing the three trig functions. So today you're going to use inverse trig functions, and you can find the button on the calculator. It's right above the regular trig function, so you'll see sine, and then you'll see sine to the -1 power. The -1 power represents the inverse. And our notes are kind of incorrect right here. So I actually want you to cross these out, and we're going to put new definitions here. So the inverse sine, so sine is opposite over hypotenuse. The inverse sine of the fraction opposite over hypotenuse will equal the angle. So if you know that the sine of the angle equals the opposite side over the hypotenuse, the inverse switches that. So it switches the input and the output. So the inverse of the sine inverse of the fraction will give you the angle measure. And then inverse sine of cosine. So cosine, and it looks like a -1 exponent. That's what the symbol to represent inverse. So inverse cosine, and then you did the fraction adjacent over hypotenuse. That will give you the angle that is right here with that adjacent side and hypotenuse. And then inverse tangent is going to be the fraction opposite over adjacent will give you the angle. And so you'll decide which inverse function to use based off of which sides that you have. All right, so these are also wrong. There was a few typos in the notes, so just ignore that. Okay, this is basically saying that if sine of the angle equals opposite over hypotenuse, then the inverse sine of opposite over hypotenuse will equal the angle. So if that, then that. And that's true for all three. So if cosine of the angle equals adjacent over hypotenuse, then inverse cosine of the fraction equals the angle. So to find the missing angle, we're going to determine which sides we have. If we have opposite and adjacent, we'll use tangent. If we have adjacent and hypotenuse, we'll use cosine, etc. Then we're going to determine which trig function to use based off of which sides we have. So again, if you have adjacent and hypotenuse, you're going to pick cosine. Then you're going to set up the trig ratio, and then you're going to use your second button to get the inverse functions. Okay, we're going to round our answers to the nearest tenth if needed. So if we look at this angle is right here, and notice our 90 degrees is up here. So across from the 90 is going to be our hypotenuse. And then this 12 is touching that angle, so that's the adjacent side. And so if I think about SOHCAHTOA, you are going to be using cosine. So typically you'd say, okay, cosine of that angle is going to equal the adjacent side over the hypotenuse, which means that the inverse cosine of the fraction will give you the angle. And we want the angle to give it to us in degrees. So just double check to make sure your calculator is in degree mode. If it's highlighted as radians, that is incorrect. It's got to be degrees. So change it to degrees if necessary, hit enter, and then close out of that screen. And then to do the inverse cosine, you're going to have to hit your second button and then hit cosine. You should see the -1 power. It's technically not a -1 exponent, so you can't put it in yourself. You have to hit that inverse cosine button. Oh, okay, and then do 12 divided by 13, or use the fraction button. Make sure it closes the parentheses and hit enter, and you should get that your angle is 22.6 degrees. And then if I wanted to find the other angle, I would just need to do 90 minus 22.6. And that would leave you with 67.4 for this angle and 22.6 for this angle, because remember that the whole triangle is 180, so this is 90, so these two have to be 90 as well. Okay, looking at this triangle, remember that this is my right angle, which means this would be the hypotenuse. And then if this is the angle, the 13 is touching it, that would be your adjacent side, and the 4 is across, so that's going to be your opposite. So if you have SOHCAHTOA, you are looking at tangent, because you want to use opposite and adjacent are the two sides that are given. You don't have a number for hypotenuse. You could use the Pythagorean theorem to solve for it. But if I just want to find the angle, I'm going to use the two sides that are given, which means I'm going to use tangent. So if tangent of that angle is equal to opposite over adjacent, means that tangent of that angle is equal to 4 over 13, then the inverse of tangent of 4 over 13 will give you the angle. So the inverse flip-flops the domain and range, or the input and output. So the inverse of the function takes in the fraction, gives you an angle, where the other one takes in an angle and gives you the ratio, the length of side lengths. So you can use the regular tangent to find a side length, or use the inverse to find the angle. So again, in your calculator, you want to do second and then tangent inverse. Make sure it shows the -1, and then do 4 divided by 13 as a fraction, or use your fraction button. Make sure your parentheses get closed off, and you get 17.1 degrees for that angle. All right, I'm going to do a couple more. Find the measure of angle T. So the measure of angle T, so we're looking at the 7 is straight across, so that's going to be your opposite side. The 18 is across from the 90-degree angle, so that's going to be your hypotenuse. So that's going to be your SO in SOHCAHTOA. So that's going to be sine. So the sine of the angle is going to be opposite over hypotenuse, which means sine of angle T is going to be 7 over 18. So then to find the angle, you're going to do inverse sine of 7 over 18, and that's going to give you the angle. So inverse sine, so second inverse sine, 7 over 18. So the angle is 22.9 degrees if you round to the nearest tenth, because it's 8/8. Okay, so this one, it wants us to find this angle T. And so if our angle is right here at T, the 87 is across from the 90, so this is going to be your hypotenuse. The 34 is touching that side with the angle, so that's going to be your adjacent. And if you think about SOHCAHTOA, the trig function that uses adjacent and hypotenuse is going to be cosine. So you're going to set it up like this. Cosine of your angle is adjacent over hypotenuse. So then cosine, inverse cosine of the side length ratio is going to give you your angle. So you're going to flip-flop the input and the output. And make sure you choose inverse cosine. So inverse cosine, 34 out of 87. So 66.995. So if I want the nearest tenth, you're going to have to round up to 67 degrees. All right. Do a couple more. Measure of angle R. So angle R is right here. So RT is the hypotenuse. So 34 is across from the angle. That's opposite. And then this one is adjacent. If you're looking at opposite and adjacent, you're looking at tangent, because tangent of the angle is the opposite side over the adjacent side. That's the TOA part of SOHCAHTOA. So the tangent of angle R is going to be 34 over 14 square roots of 3. And if you're just looking for the angle, you actually don't have to take care of the square root of 3, because it's legal to type it in like that. Like, it'll be okay. So you just have to flip it. Inverse tangent of 34 over 14 square roots of 3, and then that will give you your angle. You're just going to have to be careful when you type it in, because you want it to be 14 square roots of 3 in your denominator. So you're going to want to do inverse tangent, and you're probably going to want to do 34 divided by, and then do another parenthesis for 14 square roots of 3, and then close that second parenthesis. Because now your calculator will do 14 square roots of 3 as one value, versus if you type it in as 34 divided by 14 square roots of 3, your calculator without parentheses will do order of operations. So it will divide by 14 and then times by square root of 3. And that's not what you want it to do. You want it to divide by the whole value of 14 square roots of 3. So just make sure that you put that all in together, or use that fraction button. If you use the fraction button, which I can't remember if it's like alpha y equals, yeah. So if you use this fraction button, alpha y equals, it will give you the right answer, because then you can put everything in the denominator and it will calculate it correctly. But if you just do tangent of 34 divided by 14 and then square root of 3, the calculator will read it wrong, and that will give you the wrong answer. So the correct answer is 54.5. I highly recommend you practice typing that in. So just being cautious of that and understanding that a calculator is following an algorithm, and it's computer programmed to follow the order of operations. And so if your denominator includes a multiplication, you need to make sure to put that in parentheses or use the fraction button. Okay. Let me see if there are any other ones. I think it's good. I think you guys got this. We'll do one more. We'll do angle F. So angle F, you got lots of choices here. So you could do the tangent of angle F, and that would be, this would be the opposite, and this would be the adjacent, and 13 is the hypotenuse. So if you did tangent, you would do 5/12, and then you would do inverse tangent of 5/12 and get the answer 5/12, 22.6 degrees. Or you could do cosine of the angle, which would be 12/13. So then inverse cosine of 12/13 should give us the same answer. Inverse cosine of 12/13. Again, 22.6. Or you could do sine, which would be 5/13. So inverse sine of 5/13 will give you that answer as well. You could also find the angle E value and then subtract it from 90 to find angle F. So you have lots of options here. So practice using this inverse trig. It's pretty cool. All right. Thanks for watching. Get your homework done now.